0.5 into 600, it is giving us 300 coulombs. Charge is defined as, with a symbol Q, and the SI unit of charge is coulomb. Thus we will be finding out the amount of electric charge flowing in the circuit. We have learned the electric current and the electric circuit of an electricity, right? Now we will be learning other two more new words, that is electric potential and potential difference. What is the difference between the electric potential and potential difference? You will be learning further. That is, I want to give an example in order to understand about the potential difference between the currents. That means, for example, let us take water, right? If you keep an horizontal tube on a table and if you allow to flow the water from this side, from inlet, will it flow to the outside? No, because it will be staying like that, because it is in a stable position and it doesn't have any pressures on both sides. If at all, if you keep a tanker on the head of the or on the top of the roof, and if you connect a pipe to it, the water will be flowing out, right? It will be flowing down as fast as possible with high pressure, right? That means here one term is acting, that is the pressure, that is the force of the water. That means if at all the water is forced out, that means if with high force water are moved up or pumped out from the inlet, then the water will be coming with that much force, right? That means the force is exerted in order to move the molecules of water. Okay? In the same way, there is one term that is known as the potential difference. That is that there is a difference between the potential between the ends of a conductor also. That means in order to move the electrons in one direction or in a particular direction, we will be applying the external potential that is required in order to maintain the flow of electrons in a certain direction. What is required for us? That is, if at all you connect a battery to the conductor, right? Then if you apply the positive and negative charge, that is as shown in the figure, that is in a forward bias condition, that is positive charge for the positive terminal and negative charge for the negative terminal is known as the forward bias condition. And if at all you apply in this manner, then there is a potential, that is the voltage is developed and it will be acting or it will be forcing the electrons in the conductor to move in a certain direction only, means in a particular direction, right? Therefore, we will be getting the current, that is the electricity, that is because of the flow of electrons in particular direction only. This is because of the potential acting on the both sides. That is, there is a potential difference. That, for example, let us take the water on the top of a roof. How I said, the dams or all. When you open the gates, the water will be coming with high pressure, right? That means they are consisting of a potential energy which is in the stored form will be transformed into the kinetic energy. That is, it is moving. First, in a dam, that means if it in a tank also, if you observe, the water will be settled, right? That means they are containing the potential energy in a stored form, means if they are in a rest position. Whenever if you remove this or if you open the gates of a dam, you will be observing that water will be rushing out with a force. That means that potential energy is converted into kinetic energy. That means water is flowing with a high speed. That energy is utilized in order to produce the currents, that is known as water currents. We will be studying further. And in the same manner, here see, that is why, because that force is acting because of the pressure, that is the difference between the water molecules. That means here they are at lower pressure and here they are at higher pressure. That is, the pressure is acting or playing a key role in it. In the same manner, for the flow of electrons also, we will be using the potential difference. That means potential will be acting as a change. That means here it will be higher potential, as you see, that is we have applied the positive voltage, that is positive, and here it will be lower potential because we are connected to the negative terminal. In this manner, by the difference between the potential, that is voltage, thus the electrons will be flown in one direction, that is our desired direction. This is the term, that is potential difference. And now I hope you understood the meaning of potential difference and how it leads to the cause of the movement of electrons. Now let us see the definition of potential difference, that is the electric potential difference between 2 points. As I have said previously, the electric potential difference between these two ends of think this is one end and this is one end, other end, this is one A and this is B. The potential difference between these 2 points, that is the statement given here, the electric potential difference between 2 points in an electric circuit, this is an electric circuit, carrying some current, is the work done to move a unit charge from one point to another. That means these two ends as having the potential difference, right? Now this consists of charge, that is electrons, that is negatively charged particles. This difference will lead to the movement of electrons from one place to the other at a unit time. That is said to be as potential difference. Okay. Therefore, we will be getting the formula of potential difference, that is work done. How much amount of work is done in order to move the electrons from one place to other, divided by the charge, that is negatively charged particles. The rate at which the work done in order to move these electrons by the potential difference is known as the potential acting on these electric conductors, and it is defined as V. The symbol V is denoted for potential difference between two ends, and it is noted as W by Q, that is work done to move one charge. This is the formula for potential difference. Now let us see what is the potential difference and the definition of potential difference, right? Now we have seen the potential difference, that is the difference in the charge between the two ends is known as the potential difference. I have explained it with the example of water and the difference of pressure, right? Now we will be seeing the formula of potential difference, that is work done by charge. Potential difference is defined as the amount of work done in order to move one electron. That is, if at all one electron is here, if we try to move this electron from one place to the other place, then that amount of energy or the work done in order to move this from one place to the other is said to be as the amount of work done in order to move this particular negative charge. That is defined as the potential difference, and potential difference is defined as work done by charge, the rate of work done by charge. Work done is defined as W and charge it is of symbol Q. Now here the potential difference is symbolically noted as V. V equals to W by Q is the formula for potential difference, that is work done by charge. This is the negatively charged particle, that is electron, and the instrument used to measure the potential difference is voltmeter. The instrument what we use is voltmeter, which is used to measure the potential difference between 2 points. Now let us see the SI unit of potential difference, that is volt. Volt, the symbolic representation is V, and this is the SI unit of potential difference. And the scientist known as Alessandro Volta, he is a scientist, he is an Italian physicist. He has discovered or he has identified the units of measurement of potential difference, that is volt. Because of this scientist name Alessandro Volta, this name volt is given for this. Now let us see the definition of 1 volt. That is, 1 volt is the potential difference between 2 points. That is, for example, let us take this is a copper wire which is carrying an amount of current. That is, let us assume this as conductor. These are the 2 end points of the conductor. Now the difference between these 2 end points is known as the potential difference, V, and the 1 volt is defined as 1 volt is the potential difference between 2 points in a current carrying conductor when 1 joule of work done is moving a charge of 1 coulomb from one point to the other. It is none other than, assume this as a conductor, it is current passing through it, and one charge, that is negatively charged, is moving from here to this place. This amount of work is done as 1 joule. 1 joule of work is done. The units of work is joules and the units of charge is coulomb. 1 joule of work for 1 coulomb. See, V equals to W by Q. Work done is defined as 1 joule of unit. 1 joule by 1 coulomb is for charge. 1 coulomb of charge is known as 1 volt. That is defined as 1 volt. Okay? The rate of work done by charge is defined as the potential difference, and 1 volt of potential difference is defined as the amount of work done. That is, amount of work done equals to 1 joule in order to move 1 coulomb of electrical charge from one place to the other in a conductor is defined as 1 volt. Okay. Now we will be seeing the symbol, that is, and the formula, that is 1 volt equals to 1 joule by 1 coulomb. That is 1 volt equals to 1 joule per coulomb. Coulomb, that is denominator, is going upward. We will be keeping -1 on the power. Okay.